Hi everyone, and welcome to our last lecture. This lecture is going to be on two-way mixed ANOVAs, so it's our last type of two-way ANOVA that we will cover in this class, and thus the final confused cat GIF, which I think is quite appropriate up to this point in the semester. But you guys have been doing fantastic, and really this week it's building off of what we've been working on for the last 2 weeks. So if we take a look at our decision tree, this is the last test. Woo! Okay, so our pathway this week is parametric dependent variable, non-parametric independent variable. Specifically, we have 2 independent variables, and for our mixed, or our two-way mixed ANOVA, mixed is indicating that one of our samples is a between subject sample and the other one is a within subject sample. So, in our lovely flowchart, I've kind of simplified it from what we've had in the past couple of weeks. So still, when we have 2 independent variables and we have at least 2 levels of each of those variables, if we have 2 between subject independent variables, that ends up giving us a two-way independent ANOVA. If we had 2 within subject independent variables, then we would have a two-way repeated measures ANOVA. And when we have one of each, one within and one between, that gives us our two-way mixed ANOVA. So the goal of this ANOVA is the same as any other two-way ANOVA, where we are trying to see what the effects of each independent variable are on some dependent variable independently, so by themselves, but then we're also interested in seeing what the interaction is between each of those independent variables to see if one manipulation is dependent on the other manipulation. So for our assumptions, our kind of first 3, they have not changed over the last several weeks. So we still have random sampling. We have our normal distribution and no significant outliers for the dependent variable for each independent variable group. We have a single dependent variable that is either ratio or interval data, so it's parametric in nature. And then for our independent variable characteristics, we are going to have different assumptions that match with each of our independent variables. So when we did our independent ANOVAs, similar with independent t-tests, whenever we have a between subject variable that we are looking at cause and effect for, we have to look at homogeneity of variance. So we will do the same thing using Levine's test for our between subject independent variable. For our within subject variable, when we talked about repeated measure ANOVAs last week, anytime we have a within subject independent variable, we have to look at sphericity, which we assess using Mauchly's test. So I've repeated the null hypotheses for each of these assumptions down below. They're very similar in nature, right? So homogeneity of variance says there's equal variances between the levels of our between subject independent variable, right? So equal variances, versus Mauchly's test for sphericity, which is going to look at the variances of the differences between the levels of the within subject independent variable specifically. And the null hypothesis would argue that those differences are equal to each other. Okay, so our null hypothesis is going to be the same, for the most part, that we've had the last couple of weeks. Okay, so for our two-way ANOVAs, we always are going to have 3 main effects, 2 main effects for each independent variable, and then the third effect for the interaction. So the main effect for independent variable A is going to say that we have no significant effect of that particular manipulation on the dependent variable, and then independent variable B has no significant effect on the dependent variable which that's the null for our second main effect. For the interaction effect, we say that, there we go, that independent variable A has no significant interaction with independent variable B for the dependent variable. Okay. So then, again, when we look into this interaction further, we can see if there are significant differences of independent variable A within levels of independent variable B, or we can also see if we have significant differences between levels of independent variable B within levels of independent variable A. Once we check our main effects, or once we know what our null hypotheses are for our main effects, then we can look for them in our ANOVA tables. Now, depending on the independent variable that you're interested in, the within subject independent variable will be found in the test of within subjects effects ANOVA table. The between subject independent variable will be found in the tests of between subject effects ANOVA table. Okay, so the way that where you find them in the output is pretty straightforward if you know which factor is which. So I've kept this the same as we've had in previous weeks, so it's fairly generic, not specifying if independent variable A is our between or within factor. But once we go to the appropriate ANOVA table, we can then determine if we have a significant main effect of independent variable A. If we do not have a significant effect, we stop our analysis for that variable and we say that there is no significant effect of independent variable A on our dependent variable. If, however, we do have a significant main effect, then we need to look at our post hoc tests to see where the differences lie. And then once we evaluate the post hoc tests, we see if we have significant pairs or if we do not have significant pairs. We do the same analysis for our main effect of independent variable B. Again, I'm not specifying if this is our within or between subject independent variable. So once you look up the p-value in the appropriate ANOVA table, you either have a significant effect or you do not. If you have a significant effect, post hoc test would be required. And then from there you can determine if you have significant pairs or not, and then where those pairs lie within the levels of your independent variable B. Then we have two sets of pairwise comparisons. So all of this is the same so far, right? And then we can see which, or if we have significant pairs between the levels of independent variable A within each level of independent variable B. And we can also assess if we have significant pairs between the levels of independent variable B within each level of independent variable A. And that is pretty much it for our mixed ANOVAs. So we process through them very similarly to our other two-way ANOVAs. The only difference really is the assumptions that we end up checking, and I'll go through how and where you check those in the output in the next video.